M1 is a breakthrough chip for the Mac. Our approach with M1 was to deliver industry-leading performance and features while relentlessly focusing on power efficiency. As a result, M1 delivers a giant leap in performance per watt, and every Mac with M1 will be transformed into a completely different class of product. M1 is the first system on chip, or SoC, for the Mac. Let me show you what that means. Until now, a Mac needed multiple chips to deliver all of its features. It had chips for the processor, I/O, security, and memory. Now with M1, these technologies are combined into a single SoC, delivering a whole new level of integration for more simplicity, efficiency, and amazing performance. M1 also features our Unified Memory Architecture, or UMA. M1 unifies its high bandwidth, low latency memory into a single pool within a custom package. As a result, all of the technologies in the SoC can access the same data without copying it between multiple pools of memory. This dramatically improves performance and power efficiency. M1 is the first personal computer chip built using the industry-leading 5-nanometer process technology. With incredibly small transistors measured at an atomic scale, M1 is remarkably complex. It packs the largest number of transistors we've ever put into a single chip. M1 has a massive 16 billion transistors, and we use all of these transistors to give M1 amazing performance and leading-edge technologies. And our goal is to make each of these technologies best in class. The incredible performance of M1 starts with the CPU, which features two types of cores: high performance and high efficiency. Each performance core is designed to run a single task or thread as efficiently as possible while maximizing performance. We've been advancing it year after year. And now with the huge improvements in M1, when it comes to low-power silicon, our high-performance core is the world's fastest CPU core. And M1 has 4 of these incredibly fast high-performance cores. So multi-threaded workloads take a huge leap in performance as well. To handle lighter workloads more efficiently, M1 brings high-efficiency cores to the Mac. They use 1/10 of the power while still delivering outstanding performance. These E-cores are the most efficient place to run lightweight tasks and allow the performance cores to be used for the most demanding workloads. And M1 has 4 of these efficiency cores, which on their own deliver similar performance as the current generation dual-core MacBook Air at much lower power. And finally, M1 has our latest performance controller that determines in real time where code runs for maximum performance and efficiency. Altogether, the 8-core CPU in M1 is by far the highest performance CPU we've ever created. And more importantly, it delivers this performance at the lowest possible power. In fact, the M1 CPU leads the industry by delivering the world's best CPU performance per watt. Let's take a look. Here is the CPU performance and power usage of the very latest PC laptop chip. And here's M1. M1 delivers significantly higher performance at every power level. And at just 10 watts, the thermal envelope of a MacBook Air, you can see that M1 delivers up to 2 times the CPU performance of the PC chip. And M1 can deliver the peak performance of the PC chip while using just 1/4 of the power. This is a big deal. What you are seeing here with M1 is extremely rare. When you look back at the single-threaded performance of low-power silicon in the Mac, gains in performance per watt have been very small from one chip to the next. But when we look at M1, we see a massive 3 times improvement in performance per watt. This is unheard of. Now, what about graphics? We designed GPUs that deliver the maximum graphics performance in the thermal envelope of each of our products. This results in a balanced system with a GPU that complements the incredible performance of our CPU complex. Typically, PCs can't achieve this balance with integrated graphics. To get great graphics performance, they have to use a discrete chip which consumes a lot of power. M1 is different. With its integrated graphics, we get the best of both worlds, incredible performance and low power. The GPU in M1 benefits from years of thorough analysis of Mac applications. It's the most advanced graphics processor we've ever created, and with up to 8 of these GPU cores, M1 is capable of executing nearly 25,000 threads at a time. From teraflops to texture bandwidth to fill rate, along with its incredible efficiency, M1's GPU is in a class of its own. The transition to Apple Silicon is all about bringing its incredible performance, custom technologies, and relentless focus on power efficiency to the Mac. And M1 has done exactly that. Not only has it transformed our most popular systems, it has shocked the PC world. M1 has been amazing for so many of our customers. However, there are some poor users who need even more. And we wanted to build something great just for them. That is what M1 Pro is all about. It's our next breakthrough chip for the Mac. Now, building a Pro laptop has meant using a power-hungry CPU and discrete GPU. But a two-chip architecture requires much more power and cooling. It also means the CPU and GPU have separate pools of memory, so they have to copy data back and forth over a slower interface. No one has ever applied a system-on-a-chip design to a Pro system until today. And we did this by scaling up M1's groundbreaking architecture to create a far more powerful chip with M1 Pro. We started by re-architecting the chip fabric to enable the SoC to scale, while doubling the width of the memory interface and using faster DRAM. This lets M1 Pro deliver up to 200 GB per second of memory bandwidth, nearly 3 times M1. And its custom package supports up to 32 GB of unified memory. The M1 Pro die is built using the industry-leading 5 nanometer process technology and features a massive 33.7 billion transistors. That's more than twice M1. All those transistors deliver even more performance, starting with a 10-core CPU with 8 high-performance cores and 2 high-efficiency cores, delivering up to 70% faster CPU performance than M1. For graphics, M1 Pro features 16 GPU cores, 8 more than M1. These additional cores, along with increased memory bandwidth, give M1 Pro up to 2 times faster graphics performance than M1. M1 Pro has our industry-leading media engine that accelerates video processing while using very little power. And now it pushes even further with ProRes. It's one of the highest quality codecs in professional video production. Adding ProRes acceleration enables M1 Pro to play multiple streams of 4K and 8K ProRes video while using just a fraction of the power. It's another key advantage of building our own silicon. And finally, M1 Pro includes other advanced technologies for a complete Pro system, like a powerful engine to drive multiple displays, and additional Thunderbolt controllers to deliver even more I/O bandwidth and so much more. So that's M1 Pro. Building on the M1 architecture, M1 Pro takes the amazing performance of Apple Silicon to a whole new level. M1 Pro is unlike anything else in a Pro computer. Yet, we wanted to push the performance of Apple Silicon even further. So today we're launching not 1, but 2 new chips for the Mac. I am thrilled to introduce M1 Max. This incredible chip builds on M1 Pro and takes its amazing capabilities to new heights. M1 Max starts with a much higher bandwidth on-chip fabric and doubles the memory interface once again. This delivers up to 400 GB per second of memory bandwidth. That's twice M1 Pro and 6 times M1. This wider memory interface lets the M1 custom package support up to 64 GB of unified memory. And its die has a staggering 57 billion transistors. That's 1.7 times M1 Pro and 3.5 times M1. It's the largest chip we've ever built by far. M1 Max has the same powerful 10-core CPU complex of M1 Pro and doubles the GPU to a massive 32 cores, giving M1 Max up to 4 times faster GPU performance than M1. And it has an even more capable media engine with up to 2 times faster video encoding and 2 ProRes accelerators. M1 Max delivers all of this with industry-leading performance per watt. For Apple Silicon, power efficiency defines system performance. That's why M1 is a breakthrough. When you look at its multi-core CPU performance versus power curve, it continues to crush the latest 4-core PC laptop chip. M1 is phenomenal. And when you add in M1 Pro and M1 Max, they deliver dramatically more performance. To put that in perspective, here is the latest 8-core PC laptop chip. M1 Pro and M1 Max have higher performance at every power level. At their peak, they deliver 1.7 times the performance of the PC chip in the same power envelope. And at the peak performance of the PC chip, they deliver the same performance at 70% less power. That's a big deal. Now here's the GPU performance versus power curve of M1. And here's the integrated graphics in that 8-core PC laptop chip. M1 easily outperforms it while using significantly less power. So when we add an M1 Pro, it's in a whole different class. At its peak, it's more than 7 times faster. Now, many PC laptops add a discrete GPU for better graphics performance. So here is a PC laptop with a powerful discrete GPU. M1 Pro delivers more performance while using 70% less power. But that's not all. There are compact Pro laptops that have higher performing, yet very power-hungry discrete GPUs. They deliver strong performance, but they consume a ton of power. And on a notebook, when you consume that much power, it means more heat, noisy fans, and less battery life. So let's look at M1 Max. It delivers comparable performance while using 40% less power. Now let's compare M1 Max to the chip running in the fastest PC laptop we could find. It's a high-end system that is much bigger and heavier than a compact Pro laptop. It delivers even faster graphics performance, but it also consumes a massive amount of power. Here, M1 Max delivers similar performance while using 100 watts less power. This is unheard of, and this remarkable efficiency means M1 Max performance is outstanding, plugged in or using the battery. If you look at the compact Pro laptop on battery, its graphics performance drops significantly. M1 Max is up to 2.5 times faster. And if you look at the high-end laptop when it's on battery, the drop-off in graphics performance is even more extreme. M1 Max is over 3 times faster. This is one of the huge advantages that Apple Silicon brings to our Pro users. M1 Ultra is the next breakthrough for Apple Silicon. So far, we've scaled Apple Silicon for the Mac from M1 to M1 Pro to M1 Max. And with each chip, we've extended the architecture to deliver phenomenal performance while maintaining remarkable power efficiency and scaling the unified memory architecture. This approach has also provided a consistent developer programming model across the M1 family. And now we want to take Apple Silicon even further to achieve more extreme levels of performance for the desktop. The challenge is that there are physical limitations in creating a larger die than M1 Max. The leading approach is to use 2 chips and connect them via the motherboard. However, that approach has significant trade-offs, including increased latency, reduced bandwidth, and much higher power consumption. This also burdens developers with the need to change their code for this architecture. So with M1 Ultra, we did something truly groundbreaking. And it actually starts with M1 Max, the most powerful SoC we've built to date. With its high-performance CPU, massive GPU, and tremendous unified memory bandwidth, M1 Max is incredibly capable. And its amazing performance is delivered while maintaining industry-leading power efficiency. Yet, it's even more capable than what we've shared. You see, M1 Max has a secret, a hidden feature we haven't talked about until now. It has a groundbreaking die-to-die interconnect technology that allows us to scale even further by building M1 Ultra from 2 M1 Max die, which doubles performance. And we connect the 2 die with our innovative custom-built packaging architecture. This multi-die architecture is way ahead of anything else in the industry. And we call it Ultra Fusion. The Ultra Fusion architecture uses a silicon interposer that has twice the connection density of any technology available. It connects over 10,000 signals and provides an enormous 2.5 terabyte per second of low latency interprocessor bandwidth between the 2 die using very little power. That's more than 4 times the bandwidth of the leading multi-chip interconnect technology. The result is an SoC with blazing performance due to low latency, massive bandwidth, and incredible power efficiency. And thanks to the magic of the Ultra Fusion architecture, it behaves like a single chip to software and preserves the benefits of the unified memory. M1 Ultra has 114 billion transistors. That's 7 times more than M1. It's the most ever in a personal computer chip. And when you add it to the M1 family, you can see the huge difference in area between M1 and M1 Ultra. This multi-die architecture also supports a higher bandwidth memory subsystem. In fact, with 2 die, the memory bandwidth is increased to a massive 800 GB per second, That's more than 10 times the latest PC desktop chip. And doubling the memory channels also means M1 Ultra supports up to a staggering 128 gigabytes of unified memory for enormous workloads. M1 Ultra also offers an unbelievable amount of compute performance. It has a powerful 20-core CPU with 16 high-performance cores and 4 high-efficiency cores to crush CPU-intensive tasks. It also features a huge 64-core GPU, so it can speed through the most intense graphic tasks. It's nearly 8 times faster than M1. M1 Ultra has 32 powerful neural engine cores that can run up to 22 trillion operations per second to accelerate the most formidable machine learning tasks. And it has twice the capabilities of the amazing media engine in M1 Max for unprecedented porous video encode and decode throughput. Power efficiency affects the entire system, including enclosure design, thermals, acoustics, and ultimately performance. So the industry-leading performance per watt of M1 Max and M1 Ultra is a huge advantage for a desktop. M1 Max delivers similar multi-threaded CPU performance to the latest 10-core PC desktop chip while using 65% less power. And when we compare M1 Ultra to the fastest 16-core PC desktop chip available, it delivers 90% higher performance in the same power envelope. And M1 Ultra can deliver the PC chip's peak performance while using an astounding 100 watts less power. When we look at GPU performance and power, M1 Max delivers similar performance to one of the most popular GPUs while using 1/3 the power. And M1 Ultra delivers faster performance than the highest-end GPU available while using 200 watts less power. Combined with our unified memory architecture and custom technologies, this focus on power efficiency allows M2 to bring even more performance and new capabilities to our most popular Macs. M2 is built using an enhanced second-generation 5nm technology and features over 20 billion transistors. That's 25% more than M1. We use those transistors to enhance every feature of the chip, starting with the memory controller, which delivers 100 gigabytes per second of unified memory bandwidth, which is 50% more than M1 for even greater performance. And because M1 is so capable, users run all sorts of demanding tasks. So for M2, we've enabled up to 24 gigabytes of unified memory to handle even larger and more complex workloads. M2 features our next-generation CPU with advancements in both the performance and efficiency cores. The performance cores are faster and feature larger cache, and the efficiency cores have been significantly enhanced for even greater performance gains. Together, they rip through CPU-intensive tasks using very little power. When we look at the multi-core CPU performance of M2 compared to M1, it delivers 18% greater performance. And compared to the latest 10-core PC laptop chip, the CPU in M2 delivers nearly 2 times faster performance at the same power level. And M2 delivers the peak performance of the PC chip while using 1/4 of the power. Now let's compare M2 to the latest 12-core PC laptop chip, which needs dramatically more power to deliver an increase in performance. So it's in a thicker, hotter, more noisy system with less battery life. M2 delivers nearly 90% of the peak performance of the 12-core chip while using just 1/4 of the power. This is what we mean by the power-efficient performance of Apple Silicon. M2 also features our next-generation GPU, which now has up to 10 cores. That's 2 more than M1. Combined with a larger cache and higher memory bandwidth, the 10-core GPU delivers a big boost in graphics performance. M2 delivers up to 25% higher graphics performance at the same power level as M1, and up to 35% higher performance at its max. And compared to the integrated graphics in the latest PC laptop chip, the GPU in M2 delivers 2.3 times faster performance at the same power level. And M2 delivers the peak performance of the PC chip using just 1/5 of the power. This much higher performance per watt from M2 enables systems to run cool and quiet with exceptional battery life. Now, one of the advantages of making our own silicon is that we can quickly bring our newest custom technologies across our SoCs. So M2 also features our next-generation secure enclave and neural engine. The neural engine in M2 can process up to 15.8 trillion operations per second. That's over 40% more than M1. It also has our next-generation media engine, including a higher bandwidth video decoder that supports 8K H.264 and HEVC video. And M2 features our powerful ProRes video engine for hardware-accelerated encode and decode. So systems with M2 will be able to play back multiple streams of 4K and 8K video. So that's M2. It starts our next generation of M-series chips with an 18% faster CPU, 35% faster GPU, 40% faster neural engine, and 50% more memory bandwidth. It takes the amazing performance, capabilities, and efficiency of M1 even further.